Now we will see the energy for a continuous distribution of a charge. So definitely you have to bring the charge dq to form the spherical shell. So you need to do some work, and that work done will save in the form of energy. So that is nothing but your energy for a continuous distribution of charge, and that it is applicable for your spherical shell as well as it is applicable for your sphere also. So we will see the first case of your spherical shell. Assume that this is the charge dq that you have to brought from infinity and put it on this shell. So let the intermediate charge is a small value of q, and because of its potential is also going to increase. So we know that is potential is equals to work done per unit charge. So you can write it down now, this potential, that is work done per unit charge, then this dv. So again you can write down this is v into dq is equals to dw. Let the intermediate value on this your spherical shell is q. So the potential because of that at a distance r, you can write it down, that is a 4 pi epsilon naught r, and then again multiply by that dq. So you have to take the integration up till the final value or the total charge is capital Q on this your spherical shell. So this 1 upon 4 pi epsilon naught r is a constant, and then take the integration for this, which is q square upon 2, and the limits for it from 0 to that is capital Q, which is your w. So you can write down that work done, which is q square upon 8 pi epsilon naught r. So this is the work done, and that work done will save in the form of energy for this charge your spherical shell. So this is again, now you have to find it for your sphere. So the last one that we have derived it for your spherical shell. Now similarly we will derive for this your sphere. So obviously that sphere is different than that of your shell. So likewise n number of shells which are molded together to form that sphere. So I just consider this is nothing but your sphere, which consists of, obviously which is not a hollow, that consists of n number of this concentric circle for example, and which will form your sphere. Then again you can say that is potential is work done per unit charge. So we can say that is work done per unit charge. Then again v into dq is equals to dw. For this potential at any intermediate point, you can write it down, that is a q upon 4 pi epsilon naught x into your dq is equals to dw. So when you put a small amount of charge dq, its radius is going to increase by amount dx. So again further you can just calculate that surface charge density, which is nothing but sigma, which is total charge upon total volume. We know that it is 4 by 3 pi r cube. So with the help of this equation you can just modify this one, again just taking the limits from 0 to that is a capital R, the total radius it forms. So you have to do some work putting in terms of q and dq. You can find the value of that work done, and finally which will come around, that is your 3q square upon 20 pi epsilon naught your r. So that is the expression for your work done, and that work done will save in the form of energy. So that is the case for your sphere. Now similarly this one that we have seen for your spherical shell, which is q square upon 8 pi epsilon naught r. Similarly this one we have seen for your sphere, which is 3q square upon 20 pi epsilon naught into r. So now what will happen when I just put one your sphere and one is nothing but your shell? So they will interact with each other, and they will save that in the form of some energy. So you have to find the total energy in that case, which is nothing but your individual energy plus at the same time there is an interaction between your 1 and 2. So u1 plus u2 plus u12. Now this one, if you assume that it is your shell and this is nothing but your sphere. So we know that now because of your shell we just derived the expression. So that is nothing but your q1 square. Again we have just seen that the expression for this your shell, that is a 8 pi epsilon naught into a. Similarly you can write it down for your sphere, that is a 3q2 square upon 20 pi epsilon naught into b. Then the interaction you can write down as a q1 q2, again that is nothing but the 4 pi epsilon naught l. So where l is the distance between the two your shell and sphere, considering both of them as a point charge, you can find the total energy in this case of your sphere.